y-axis, is it? Around the y-axis, do I have a hole in the center of it? No. So around the y-axis, it's going to look more like this. If I rotate that around the y, it would look like this. I don't know. That's kind of a good enough, I guess, right? This around here, be like a tabletop or something almost. I don't know. Whatever you want to call it. Is that close enough? Do you see it? All right. That has a different volume than the other axis of rotation. So we need to figure out what it is. So what do you see as a potential problem then, if we're going to do it that way around the y-axis? I should also label that axis of rotation. If we're going to go this way, right, and we're going to create washers or disks, then which way do my rectangles need to be facing? Horizontally, don't they? I need my rectangle to look like this, so that when I wrap it around, I create the disk that I need, right? So this is the first time you'll hear me say this. I'll say it several times, though. When you're using the method of disks or washers, okay, which is what we're doing, your rectangle will always be perpendicular to your axis of rotation. This is perpendicular to my axis of rotation. In the last problem, my rectangle was perpendicular to the axis of rotation. There is another method called the method of shells where it's the opposite. Your rectangle will always be parallel to your axis of rotation. So that's what distinguishes the two methods, one we haven't seen. All right, here we go. I'm going to try and transpose this picture below it because my axis of rotation is here. I'm going to bring my axis of rotation down below. I'm going to draw a little rotation. I'm going to bring my rectangle straight down. You may think this is kind of childish to do this drawing, but trust me, it'll help you when we start moving these axes of rotations to different locations. Because we're not always going to use the x-axis and y-axis. We can use basically any line we want. So, what's that? Yeah, so right here, right, this outer one right here is going to be this red curve. And then what about the inside? What about the inner one here? Is this one right here? Yes? So we need to determine, what's it? Okay. We need to determine if we were standing on the axis of rotation, right here, looking out towards our rectangle, which is going to become our disk, what is the outer radius? So what is this distance from here to here? Yes. 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 Which is no and yes at the same time. Natural log of x, correct. Y equals natural log of x, but you can't write it that way. That's right. You've got to solve for x. You have to write it as a function of y instead of x because your rectangle is sideways. Right? Do you agree? Because we're going sideways, the distance from here to here has to be written as a function of y. Right now, the way the problem was presented, this was given to you as y equals natural log x. That would work perfect if it was a vertical rectangle. The height would be natural log x. So how can I get this solved for x? E on both sides? And that gives you e to the y is x, right? So that outer radius is actually what? E to the y. That was a little tricky, right? You have to pay attention to that. What about the inner radius? This was the out. X is 0? Yes. So 0. That's my inner. Nothing else in the formula really changes. You're always going to use that same format. Pi, integral, a to b, you'll have to figure that out. It'll be outer radius squared minus inner radius squared, d whatever the variable is. I'm going to put this up. Remember I said I'm going to box something and do a cartwheel and all that? I haven't done that yet. I'm going to put something up here in a minute. I'm going to do a cartwheel. Yes. That's how you'll know that that's important. All right? How about our limits of integration? 1 to 2. So again, we're going different now because we're integrating with respect to y. So our limits of integration have to be our constraints on y. Unfortunately, in this problem, the region is bounded by 1, y equals 1, and y equals 2. So that shouldn't be anything we have to figure out. I'm ready to do it. Let's do it. Here we go. The volume will be pi integral. You said 1 to 2, right? 1 to 2. Outer radius squared. Outer radius, e to the y. So e to the y squared minus, what was the inner radius? 0 squared, and then dy. That's just pi integral 1 to 2 e to the 2y, because we all learned on that test on number 5 that e to the 2y is e to the y squared, right? And can you integrate that? One half e to the 2y. So you have to look at this as being a linear expression inside of the e. So when you integrate it, you have to scale by the a that's in front of the variable. So it's 1 over a e to the 2y. And that's going from 1 to 2. Let's plug in 2. What do you get when you plug in 2 here? Pi over 2 is the same as pi times a half. E to the 4th minus, now plug in 1, pi over 2 e squared. Oh. Yeah? It's good enough. We could get that as a decimal, but who cares? Okay. We got 30 minutes still. How are y'all feeling? It's all right? Y'all following this? All right, so let me put the formula that'll be followed by the most impressive cartwheel you've ever seen in your life. You'll be thinking Cirque du Soleil. You'll be thinking, I should be doing something else with my life other than being up here as soon as you see this cartwheel. All right, so the Grandmaster formula, right? For volumes of solids of revolution when we're using disks or what we call washers. It's the same thing. Disks and washers is the same method. The only difference between a disk and a washer is when you do a disk, the inner function is 0. A washer is only created when the inner function is something other than 0, because it cuts out an inside of and it creates the washer. But they both have the same formula. The formula is that the volume will be equal to pi integral a to b of the outer radius squared minus the inner radius squared d what? Could be x, could be y, right? So what do you want me to write? D question mark, okay. And that could be, because that's really what it is. And actually this a and b, those could be limits on x or y. So, you know, it varies. The most important thing for you to understand is that the general formula always has a pi in it. You always have to find the outer radius, and you always have to find the inner radius. If you can determine that from your picture, you're in business. And on your exams, I do want pictures. I want to see you coming up with this formula on your own, because I told you on the test I'm not going to require that you actually evaluate the integral completely. You just have to set the integral up and then just move on. But that means I want detail. Pardon? You don't have to integrate. Just set up. It'll just be set up the integral. So here's an idea. Here's an example of a problem on a test. Sketch the region. Sketch this region. Rotate it about the x-axis. Now rotate it about the y-axis. Now rotate it around this, that, and this. I'll probably have you take one region, rotate it around 5 different things. Each formula will be different. So you have to set up the formula for each one. That's the way a problem would look. All right? Okay, let's try. Let me try to adapt this problem a little bit. Let me do something a little different. How about we take y equals e to the negative x, y equals 1, x equals 2. Take that region and do it about y equals 2. Not the y-axis, not the x-axis, about y equals 2. And I'm really hoping that this problem is going to help illustrate how important it is to draw a good picture. You all ready? Here we go. When I was doing the homework videos for these problems, there was a few where I drew the picture and I realized that my picture was too small, like I needed to focus more attention on one part of the picture. So I just, say in the video, I'm going to erase this and start over because I know now that I've drawn it that I'm going to have to blow it up a little bit to be able to see what I need to see. So be prepared to have to write something over, draw it again. All right, y equals, let's take care of the easy stuff first. Y equals 1, horizontal line, right? Boom, this one right here. Try it, how about here? I'm kind of taking a guess. See, if I were to be like y equals 1 right here, that might be too small. So I'm kind of guessing that my picture's not going to get crazy big and I'm going to be up at 10 or something, right? So y equals 1 is this line right here. What else? I think I'm going to do y equals 1 here. What's next? A vertical, x is 2, so that's right here. And y equals e to the negative x. Nobody wants to see my cartwheel. I thought for sure y'all would be like, where's the cartwheel? I can't do a cartwheel, okay? I've never been able to do a cartwhel. I lied to you. I lied to you. I straight up lied to you. I'm saying it on B. I lied to you. I apologize. I was just trying to get you to anticipate it, that's all. It's for your own good. All right, e to the negative x, what does that look like? It's e to the x flipped over the y-axis. It's the reflection of e to the x. So it looks like, goes up like this. Never hits the x-axis, right? So it comes down and something like that. E to the negative x. Yeah. Where am I rotating this around? Y equals 2, which is above this, isn't it? It's above this. It's up here.
Do you have to make a distinction whether you want to rotate it like whether he chooses to rotate?
Ask your question because I think I should answer it to make sure. You probably have the same question someone else does.
No,
does it matter?
No, because if you ask to do it about why you're going to rotate it like that, not like that, like you're going to rotate it.
I'm going to go like this with
Yeah.
it. Yes?
There's no way you can do it like that because I'm not asking that.
I'm not asking about this.
Yeah.
If I said y-axis, then yes.
My answer to my question.
Okay. I thought what you were asking, does it matter if you rotate it up and around or back into the board and around? I thought that's what you were asking. But it's the same solid. So, okay, everyone see this? Okay, now to the right. Oh wait, let's draw the region. I didn't even kind of like shade it in. It's this region, right? My rectangles are going to have to be perpendicular to the axis of rotation because that's the only method I know right now, right? But everyone agree that that makes the most sense for your rectangles to be in here like this? Because as you slide this rectangle to the left and slide it to the right, the function on top and bottom are always going to be the same. It's not going to change, right? It'll always be the green on the bottom, the blue on the top as I move that left and right. Okay, so what did I ask you or suggest that you do at this point once you've got all this information down here? Yeah, just do a little separate little transpose your picture over here. And again, I think this is the most valuable part of the whole exercise here. There's that. A rectangle is coming over here, like this. The green is going to be dictating what happens on the bottom. The blue is dictating what's happening on the top, right? The blue happens to never change, right? My axis of rotation is up here. My niece can do cartwheels. And she was in my living room the other day doing cartwheel after cartwheel. She had like 5 different versions of cartwheels she could do, different names for them and stuff. I told her I couldn't do a cartwheel, and she just kept doing them in front of me just to rub it in.
Is that what you want to do? Like you want to do it?
I really do want to do it, but I've never really tried since I was a kid, you know, so I need to. I'm done. I'm past the age limit. There's a certain age. That's it, man. That's it. You need to be going the other way. Start looking for canes.
Didn't
All right.
mean that.
All right. I need to get back to this. I'm losing focus. Everyone okay with this picture? What is it I said you had to look at? The most important part for the integral is to figure out what 2 things? The outer radius and the inner radius, right? The outer radius is the distance from the axis of rotation to the outer edge of the rectangle, right? The axis of rotation is here. The outer edge of the rectangle is actually which part of it? The green part, right? The distance from here to this edge is my outer radius. The distance from here to here is my inner radius. So the distance from here to here, I have to figure out. And the distance from here to here, I have to figure out, right? This is the out, this is the in. But it's not as simple as just, oh, it's that. It's the green function. Because the green function, from the x-axis up to the green function, is the height of the green function, isn't it? So the distance from here to here is what? E to the negative x. That's just here to here. The distance from here to here is what? 2 minus, see, because from the x-axis to here is what? 0 to 2. It's 2, right? So if from here to here is 2, then from here to here is 2, take away the e to the x. So this is 2 minus e to the negative, I said e to the x, e to the negative x is what I meant to say. Do you all see that? That is your outer radius. The inner radius is found the same way, but this time you have to figure out what this distance is first. What's that? That's 1, right? That never changes. The distance from the x-axis up to the blue is 1. So that means the distance from the blue back to here has to be what? 1 also. 2 is the whole distance, 2 minus 1. This will always be 1. And that right there is the inner radius. Any questions? No cartwheel. It's not happening. Bless you. We sure? There's no... Everyone understands why this is not e to the negative x minus 2. Right? It has to be 2. Take away the e to the negative x. All right. I'm ready for integral. As long as we have limits of integration. Are we going to have limits of integration? Since we're doing vertical rectangles, it's with respect to x, which means we need limits on x. They are 0 to 2, right? So the volume is pi integral 0 to 2 outer radius squared minus inner radius squared. Don't erase it. It's too late. Dx. Two minus e to the negative x is our outer. The inner is just 1, isn't it? Questions? Dot, dot, dot. So you take that the rest of the way. But that would be the setup of it. On a test, that's what I would want. That setup. All right. Yes?
Just trying to find the total volume, but couldn't we also set, like, this is probably not the best way to do it, but you could pretty much skip everything where you're doing the 2 minus e to the x, because essentially the volume, if you rotate around the x-axis, would be the same as the volume rotated around y equals 2. But the thing is, you'd have to sketch it.
Hold on. Let me keep up with your thought here. The volume around the x-axis is the same as the volume around this?
Yeah, of the shaded area.
This region right here.
Yeah,
If I
know it's not
rotate
gonna
it,
work with other ones, but right now.
what do y'all think? Let's see if we all agree with this or not, with Ron or not. If I take this region, let me first make sure I understand what you're saying. If I take this region and rotate it around the x-axis, I'm going to get a volume.
Yeah.
You're saying that's the same as rotating around that one.
Yes, but it's not this. It's volume within the shaded area.
Is that what you're saying?
I don't think so.
This instance?
Just think about this. Think about this simple idea. If this goes around the x-axis, how big is the hole between them going to be? Just that big, right? Right? So I barely get my hand in there. It'll open up, but I can barely get my hand there. If I take this around here, how big is that hole going to be? I get both arms in there, right?
It's gonna be a total.
So that's going to be a huge volume that goes through. Make sense? Yes?
If we do rotate it above the x-axis, what is going to be the inner radius?
The inner radius would be e to the negative x. So look, yeah, if you're going around the x-axis instead, which is here, the inner radius would be this distance, which is the green function, which is e to the x. The outer radius would be 1. What I'm going to do now is I want us to do the exact same problem, but I want us to rotate it around y equals negative 2. All right? So instead of having the rotation axis up here, where am I putting it? Down here. And let's see how it changes. So same problem. Same problem, just change it to about y equals negative 2. And since I erased it, and I started to erase it, and you're going to have to redraw it anyway, I'll take the time to redraw it. Dang, man. Y equals 1. Just like that. This one came down like that. What was the x? It was 2, right?
Yep.
This was 2. So our region was right in here. This time, though, our axis of rotation is down here. Notice that I'm using a dotted line for the axis of rotation, because that's how I help remind myself it's not the x-axis. That's the x-axis. This is the axis of rotation. My rectangle should still be vertical. And now I'm going to take that whole picture and transpose it over here to the right side. I like to bring over my axes first. There's the x-axis. I'll even label it x-axis. Over here, my axis of rotation is here. Can y'all see that those are supposed to be like two arrows curling into each other? That's what that is. My rectangles here. The bottom edge of the rectangle is changing as a function of the green one, right? The top edge of the rectangle is never changing, but it's the blue curve that's dictating that, right? Are y'all caught up with me yet on the picture? All ready? All right. Let's have a volunteer for the outer radius. Volunteer. Anyone want to volunteer the outer?
-3.
Say again?
3.
3. Look at it as an absolute value. Good. So look, we want to know the distance from the axis of rotation to the outer edge. The distance, right? The distance. Distance, we measure that as a positive number. So first we have to go from here to the x-axis, which is what? 2. Positive 2, right? 2 units to get to here. Then we got to go from here to here. From here to here is what? 1, right? Because that blue function is 1, so that's 1. From here to here, as an absolute value, is 2. So the outer radius, the total distance from here to here, would be 3, and that's our out, right? Who wants to volunteer the inner radius? Go ahead. No? No? What do you want?
2, well, I guess it would be 2 minus e, or 2 plus e.
2 plus e to the negative x. What do y'all think? E to the x minus 2. Well, let's think about it. If you're standing here, what is the distance going to be from here to that edge if you had to walk it, right? So when you walk this, how long is that? How far did you walk there? 2. And then how far do you walk to get to there? E to the negative x. So it's a total distance as opposed to negative 2 plus this much, right? So from here to here is this number. That's our inner. And so the integral becomes integral from 0 to 2 still. That didn't change. Pi. Outer squared, right? Minus inner squared dx. Whatever that is. Where? Positive 2, not negative 2. On here?
Yeah.
Well, remember, the rectangle slides left and right as a function of x, right? And so the x is actually the distance from here to the rectangle, and that x has to vary between 0 and 2. I've got about 10 minutes, so I'm going to just introduce you to this next idea. Y'all good for 10 more minutes? You're going to be all right? We could practice cartwheels for 10 minutes.
I can do like a semi-wheel.
Okay, I want to take y equals x minus x minus 1 squared and y equals 1, and I want to rotate this about the y-axis. I've got to be kind of quick here because I'm running out of time. Y equals 1. It's the easier one to graph, right? What does x minus 1 squared look like? Parabola, right? Where's the x-intercept? Where does that thing hit the x-axis? At 1? What is the value of that at 0? One, right? What is the value of it at 2? One. Okay, that's what you would get. Again, I don't have time for that, but there's the graph, right? I want to rotate this region bounded by the 2, which I hope you see is this, around where? The y-axis, which is this. What's wrong? Yeah, I'm going to have a horizontal rectangle to do this, right? And what's wrong with using a horizontal rectangle? It's touching the same function. Because the red one is not a function. You cannot rewrite this red one as a function of y because it's the same function. It would fail the vertical line test that way, if that makes sense. So you can't really do it, can you? The method of washers does not work for this. The method of disks does not work for this. But there is a way, and it's called the method of shells, and that's what I want to introduce you to. So keep this in mind as I show you how the method of shells will work, all right? So we're kind of stuck on that. Yeah, I've got enough time. This is really actually kind of cool. All right, don't worry so much about copying this down because the speed at which I'm going to do this, it'll be probably impossible for you to keep up. But you got a video, you can go back and watch it. All right, so check this out. Let's say I have a region like this, and I have something between A and B here that I want to wrap around the y-axis. We can't do it with a horizontal rectangle because of what I just said, right? So this is truly a function of x, but it's impossible to write as a function of y. Here's what I'm going to do instead. Instead of taking a horizontal rectangle and wrapping it around like this, I'm going to take a vertical rectangle and wrap the vertical rectangle around the x-axis. Around the y-axis. What geometric figure would I create if I wrap this? Well, hold on, back up. If I move out to a certain value, let's say x, that's where I draw my rectangle, right? That x varies between A and B. Okay, I take that slice, I wrap it around, what do I get? What does that look like geometrically? A cylinder, but it's hollowed out in the middle, right? It looks like this. Yeah, it looks like this, doesn't it? That's hollowed out in the middle. This thing wrapped around, right, comes around, goes back into the back side of the board and comes back around. I get this shape. Does everyone see that shape? Okay, that is a cylinder, yes, I agree. We can find the volume of that perhaps using a cylinder, but I want to do it a different way. What I want to do is I want to take my imaginary scissors and I want to cut this thing right here, all right? I'm going to take it, I'm going to roll it out, I'm going to lay it flat. So if I lay this thing flat onto the ground, after I've cut it and put it open like that, it'll look like this, won't it? Which is a three-dimensional rectangular shape. It's not a box. We call that a parallelepiped. That's the technical name for it. So we've got this shoebox-looking thing. It's supposed to be taller than that, right? This one looks taller. That's supposed to be the same height, right? So how tall is this right here? How tall is that? Because if I find length, width, and height, I've got the volume of that, don't I? How tall is it? It's just the function. Look, remember, that little rectangle's in there, right? That rectangle was this, wrapped it around. Wasn't that just f? That was just the function's height. That's just f of x. Yes? That's how tall it is. What's the thickness of this thing? It's this thickness, right? Which is dx. So that thickness is dx. And then this is the hardest part of it. How long is this thing? Yep, you had your thing here, right? We cut it open, we rolled it out flat. So this length is actually the circumference of the circle right there, isn't it? But the circumference of the circle means we have to know, like if we look at that piece from the top, right? We need to know the distance from there to that edge, which is what? It's just x, right? That was the distance from here to here. That's what created that radius. So the x is kind of like the radius of this thing, isn't it? And so if this is circumference is 2 pi r, this is actually going to be 2 pi x. And so the volume of that little slab that we've created, the volume of it is those three things multiplied together, which would be what? Give me the constants first. 2 pi. And then how about x, f of x, dx? That would be the volume of that slab. And what do I want to do? Add them all up. And I want to let x vary between where and where? A and b. And this is the formula. Okay, the formula is the volume of this wrapped around the y-axis will be 2 pi, because it's a constant, integral a to b of x times f of x dx. See that? Using this, I never have to actually switch it to a function of y, do I? I can leave it as a function of x and use this formula. So this allows me to get around it. So I think there's something to be said here in my last minute while I'm writing the homework down. Whatever it is that you decide you're going to do with your life, I'm not trying to get too profound here or anything. No matter what it is, the thing that you want to study or do that interests you the most, that you have a passion for, try and understand it more than just know it. Instead of knowing it, just try and understand it more. What's that? 7.2, page 378. I don't know if what I'm saying makes sense, but let me try and illustrate my point. I'm going to turn my video off. But the point I'm trying to make is